Alright, we'll pick up homework 2-1 with question 6. So we've got questions 6, 7, and 8 to get through. The correct answer for this, by the way, if you just want to jump ahead, is 2.5 newtons. And this question actually is significantly easier than it at first looks like it's going to be. It wants to know just what is the component of the net force parallel to the floor. And so the reason this one's a little bit easier is it doesn't even care about the entire net force, it just wants a component that is parallel to my angled floor here. So I'm going to start by just repositioning this. So I'm going to take my floor and tilt it, right? So then force 2 is perpendicular to the floor. Force 1 would be parallel to the floor, pulling this way. And then force 3, which is the one that I didn't get the label down here, but force 3 would be pulling down an angle. And then breaking this up just a little bit more here, right? Because this angle is 30 degrees, this angle would be 30 degrees as well, just by using a little basic geometry, right? So that tells me this angle is 30 degrees. So again, I've got my forces. Force 2, they told me here, is 8 newtons. Force 1 is pulling back to the left at 1 newton, and I'm going to go ahead and make that a -1 since it's pulling to the left for my diagram. And then looking here, I just need to break up one of my forces into components. So I know that this is 7 Newton hypotenuse. The reason that this question is actually significantly easier, though, is since they only care about the component of the net force, they don't want the whole net force, but just the component that is parallel to the floor. I really don't care about the 8 at all, because the 8 is completely perpendicular to the floor, and so it's not going to have any impact on the parallel components, right? Similarly, when I'm breaking up this triangle down here, I really don't care about my vertical component of that triangle at all. The only component I care about is this sine component down here, because that is parallel to the floor. So I just do 7.0 times sine of 30, which sine of 30 is just 1/2, so 7.0 times 1/2 is 3.5. So what that tells me is then I only have two components that are parallel to the floor. This negative 1.0 newtons pulling to the left, and this positive 3.5 newton force pulling down the ramp or to the right based in this picture. So the net component, the net horizontal component, would be 3.5 minus 1.0, which is 2.5 newtons, and it would be down the ramp or in the positive direction based on my graph. Alright, so 2.5 newtons, maybe I'll even just say down the ramp, right? But anyway, so this one, some of you maybe had started by finding the overall resultant, the total net force, and then breaking that into the components. Nothing wrong with that, it's just a little bit more work than you need to do. Right, so hopefully this one wasn't too bad, no matter which way you chose to work it. Question 7 was also hopefully pretty easy for us. This one's short enough I'm not even going to worry about writing the right answer. This one's just getting us comfortable with the vector notation, right? If I were to take vector A plus vector B, I simply add it up component by component. So my resulting vector C would be 1 plus 3, so it would be 4i, which tells me the horizontal component is 4, and then plus negative 2 plus 4, so that ends up being 2j, which tells me the vertical component is 2. So if I'm thinking about my actual vector here, again, when you see this, what I do need you guys to be comfortable with, when you see this, what this is really telling me is C is going off 4, it's going up 2, which means this is my actual vector C, right? This is my actual vector. So it asks me to find the magnitude and the direction, but if I know this is 4 and I know this is 2, it is easy enough to do that, right? So simple Pythagorean theorem, the magnitude of C, and I'm using just the absolute value here to represent the magnitude of C, right? The magnitude would be the square root of 4 squared plus 2 squared. I'm just doing the Pythagorean theorem. So either the square root of 20 if you want to leave it exact, which would be fine, or if you want to round that off, it's about 4.47. And I don't have units here, so I'm not necessarily worried about the units. It does also, however, ask for the angle. If I were to find theta, right, if I were to find theta, I would just do tangent inverse of 2 over 4, or 1/2, and so I find that angle to be about 26.6 degrees. And so as I'm describing this, since it's not north, south, east, or west, and most of the time when we have these vectors like this, we should avoid north, south, east, and west because we don't have those cardinal directions. So I'm just going to say 26.6 degrees above the x-axis. So anyway, so I've got my angle, and I've got my C. I've got my magnitude. Right, so easy enough, hopefully, to find that. So then for question 8, my final question here, if you do want to just check the answer and be done, you are good at the answer of 31.78. So if you got that and you got that confidently, feel free to finish this homework assignment and stop playing this video. But if you do want to see this at all, feel free to keep watching. Alright, so this one they want us to find, and again the absolute value bars representing the magnitude of when I take and I add these two vectors together. So the first thing that I want to do is I want to identify what are the components of vector A and what are the components of vector B. Right, so the components of A, well, if I just simply look at my graph, it goes left 3, so negative 3, and it goes down 3. So my components for A would be negative 3, negative 3. If you wanted to write that in terms of I and J, you definitely can, but I'm just going to go ahead and leave it in this vector notation. Right? Do the same thing for B. Well, B goes left 2 and up 4. Keep in mind my x component is coming first, so negative 2 and then positive 4. So I've got my two vectors. The only thing I now have to be careful about is what they actually do. So I'm going to multiply A by this scalar of negative 5, and I'm going to multiply B by this scalar of 4. And this goes back to hopefully what a lot of you guys have seen in pre-calc, and that is that I can multiply a vector by a scalar. I just distribute that scalar to each one of those. So if I take A and I multiply it by negative 5, I just end up with 15, 15. I distribute the negative 5 to each of those, and I've got it. Alright, if I take B and I multiply it by positive 4, same deal, I multiply each of those components by 4, and I get negative 8 and 16, positive 16. So then if I'm finding my total, now in this case I am just adding them up, I'm not subtracting, so I don't have to do anything too crazy. So I'm just going to add those up, and I just add them up component by component. So I would get a vector that has a horizontal component of 7 and a vertical component of 31. So again, if I was actually thinking about the result of multiplying these and then adding them up, the resultant would actually be 7 this way and 31 up, But it doesn't ask me to draw this, it just asks me what is the magnitude, And so to find the magnitude of any vector, I just do the Pythagorean theorem using the resulting components here. So if I want to find the magnitude of negative 5a plus 4b, the magnitude of that would be the square root of 7 squared plus 31 squared. So then as I do that, I just have to be careful about my calculation, and that's where I get the 31.78. So anyway, once again, they don't give us units, so if you just wanted to say units, that's fine. But that's the magnitude of my resulting vector. And then keep in mind, sometimes they may ask you to find the angle as well. But hopefully this one wasn't too bad. Hopefully the first homework assignment here for Chapter 2 was a lot of review. If you do feel uncomfortable with any of this stuff and want additional practice, just come find me and let me know, and we can work on this in more detail in class or in person. But anyway, not too bad, right?